everyone. I'm Hamza. I'll just introduce myself in a minute. But what I want to talk to you about is looking at semantic search. How can you sort of build it from scratch? I have a few examples of the building blocks and how do we actually make it work for us. And the major reason I sort of selected this topic and I've been working on it is we see a lot of research which is done on benchmark data sets which are from Wikipedia, data sets which are made processed and already made. And the biggest challenge is that when you apply them to real world data, they may not work the way we want them to work. So it's always interesting to find out who's Arya's father is from Game of Thrones, Arya's Stark, Ned Stark. But you want to go beyond that. You want to go beyond onto something that you can build better and sort of have a way to understand, is my search really working? And when I build this model or which LLM model can really work for me. So this is sort of like a baseline of the discussion. With that, I'll just want to introduce myself. I'm a applied ML engineer. Well, the title is Research Science Manager at Google. I have about 15 years of experience in machine learning. I'm an adjunct professor currently at University of Minnesota and Santa Clara University. I have an MS, I have an MBA, and I have a bachelor's in computer science. Please feel free to reach out to me on LinkedIn, connect. I'm always excited to learn what people are up to and always ready to share, new ideas. I'm always doing research on something. So it sort of keeps me going, keeps my mind turning. And this project, this conference presentation that I'm showing is also an outcome of one of the projects that I was working at on the site. So we all know that most of us know this phrase: a man is known by the company he keeps. It's been this phrase we've known for a very long time. It has been given down to us in many ways, and it's really old. It's from prehistoric times. However, there is one more phrase that I'd really love to talk about is you shall know a word by the company it keeps. And this phrase was coined fairly recently as compared to the previous one. This was phrased in 1950s by a British linguist who specialized in contextual theories of meaning and analysis. So for instance, one of the biggest things that we know about LLMs is that they're good at predicting what the next word is. They're able to predict in a sequence of word what is the next word that we can get out of it. However, it is built on the fact that you have a context around by the positioning of the words in a sentence. And that is something that we have learned from, that is something that is so popular to us. And not now, it's in 1950 that somebody came up with this phrase, and it makes so much sense that context is built on how the words are positioned and where do they exist in a sentence to build something out. I want to talk one very important thing, the value of context in NLP models. Context is something that we are learning more and more, and that's the differentiating factor between a keyword search versus what you see in Chat GPT. It sort of understands what you're saying in most cases and try to recreate from what you've asked. So the goal of a natural language processing model is to answer 4 questions. Who is talking? What are they talking about? How do they feel? And why do they feel that way? So in reality, the last question is a question of context. And to be honest, when you work with these LLM models and you're trying to build the opportunity around that, how useful they can be, that is the last part is where we are looking the most. Why do they feel? Why does a person feel that way? The way Sid said it, and sort of helps come up with the context of what we are talking about. Now, I want to take you through a user journey of how I built semantic search from scratch, from whatever open source tools we have. What were the different things, and where am I at this moment? So the preamble of this is the necessity is the mother of invention. So a little background about me. I like to travel a lot. My wife and I, we both travel a lot in the past few years, ever since COVID has sort of gotten easier. We have traveled a lot. And every time we would go somewhere, we would have to search for a hotel. We would have to search based on, and I think that's something that what everyone does. They search for a hotel, or they go to Expedia. They start with searching for a hotel. They put in the city name, the check-in, the checkout date, and then they go through a whole sorting list. based on the location, based on the reviews, based on the pictures. So they keep looking for different set of things. And it's a very, very long process. It takes forever to find something that meets your that that works out for you. So what we suggested, or we thought about doing, is that what if we could create, using the same basics? For example, put in the date, check in, check out, we put the city. However, we actually were able to add something more than that. What if we were able to like add a long text to get more granular choices, such as, I want to go to New York, I want to live near Times Square, I want free breakfast, I want it to be cheaper than $100 per night, and I want to go on 2nd of June, which is really kids friendly and has a swimming pool, and I want to stay there for 8 days. Now, this seems a lot of requests in one query. But think about it, when you, as a human being, if I'm a travel agent and you're trying to book a hotel with me, the thing that you would do is you would come to me and you would say all these things. You would say, hey, I want to go to New York, but I want to live near Times Square. I want to see if there's free breakfast. I want to get something that's cheaper in a certain dollar value. I want to go from this date to this date, and it should be kids friendly. So this is the same thing that, what if we could build a system that could do the same things and try to get 4 out of 5 things, 3 out of 5 things, but not break. Like if you put this query anywhere else, pretty much everything, you won't get the answer that you're looking for. However, what we wanted to do is, how can we build all of this and sort of go from step to step, one step to the other, and say, what does it take to build something like this? So the way we did is that we started with, we wanted to collect a lot of data. So we started, okay, where do we find this data? So we scraped TripAdvisor, which allows you to get information for free. We have 250 hotels. For each hotel, you have a description, you have the location, you have the amenities, you have the star. So you have the factual information about them. And for each one of the hotels, we scraped up to 1,000 reviews. So this is the way that we built our corpus. Then the next thing we did is that we built a real-time hotel API, which sort of gives you an information that in the check-in, check-out date, how do you generate the price point? And then from there, we sort of started building our online and offline models for embedding. And finally, there was a query API. Now, this is a lot of information that I just shared. There's a lot of steps. So I sort of try to build into a diagram, sort of, I'll start with the top. So on the top, we have a user who is using an API. It could be on Messenger, it could be on Slack, it could be on any version. And you actually speak to it as if it's a chatbot. We call this this workflow, this entire flow, as Athena. And what it does is that it has you are connected to it through a certain webhook, and you speak to it as a chatbot. And based on whatever requirements we use the named entity recognition to identify the geographical location, some factual information we have about it, some money related to it. So we take the query, we generate on real time what are the different aspects of it. Then we have the first bar, the first arrow you see is a real-time feedback sort of feed, where you get the price from the check-in, check-out date. So that's a live API which is running. The other thing that we have is that we have taken remember we took those reviews and all those information about the hotel, we saved it as an embedding into an offline model, and we sort of ran multiple versions of it to sort of see that based on the queries, which would be a good way to embed them and create data set on them. And in the end, what we would get is one is the real-time feedback on the pricing, and the second is is from the offline model that we could get the queries from the most relevant hotel information based on what the query is for you. From there, what we'll do is we use multiple techniques to get the data in the form reduce the sample space of the hotel results we have. So basically, we wanted to see what kind of relevancy we can get. So we sort of created a three-tier approach. The first approach is we did BM25, which is a very popular lexical search version. We used BM25 to sort of narrow the space of answers. So for example, if you have 2,500 hotels, you reduce the space to 100 hotels. On the left, you have the by encoder, and then on the right, you have cross encoder. The by encoder basically utilizes in a parallel fashion the query and the embeddings and sort of come up with a cosine similarity score between them, which is you take a query, you look at all the embeddings of the hotel that you have gotten from the BM25, and you sort of get that information reduced to, let's say, the top 15 or the top 10 based on cosine similarity. And then finally, what we do is that we run a cross encoder, and the cross encoder is responsible for creating a classifier, which is between 0 and 1 on how close that information is. So in a nutshell, if we were to put it all together, what we did is you wrote the query, you wrote an entire set of query. From that query, we generated named entity recognition, the NERs. So we were able to identify what are the different building blocks of that query. From that, eventually we had something which which sort of refers to the that you have, these are the top 5 most relevant hotels based on the information that you have provided. Now, what I want to do is I want to take a breather and sort of talk about an example over here. So instead of New York, I wanted to go at that point when I was building this, I wanted to go to Paris. So I built something and I want to show you how it works. So let's say you have, I'm going to refresh this. Let's say you have a query. So this is just based on Paris, so you don't need to identify anything. So let's say you want a hotel near Eiffel Towers with big rooms and good internet service, right? And then what you can do is you can put in a check-in, check-out date. So we have January. Let's say we have, I'm just going to pick up some random dates. So let's say we got 15th, and over here you go March, and then you go to, let's say, 20th. So you have sort of 5 days, and you want to build something over here. So what you do is you run this, and what you end up getting is sort of the results from the top 5 results from the BM25. So these are the set of results which you see. Then what we do is we then run the by encoder. So sort of like a funnel approach. And initially you see that you had a hotel with this name and there was information, but it didn't really feel like it had Eiffel Tower or it's anything related to it. However, as soon as we introduce the by encoder retrieval results, we start to see a very interesting flow that you at least see Eiffel in your results. And then finally, what we have is the cross encoder, which is a layer on top of the by encoder, and it sort of creates another list, which which sort of gets to the point that, okay, all these hotels based on the cosine, first the BM25, then the cosine similarity, and then the next part is that how, based on the classification of how close they are to each other, we're able to build a sort of a search engine which looks like this, right? The evaluation criteria which we can use is sort of, there are 2 versions. There is an offline metric and an online metric. The offline metric is the order, and it's an order. There's order unaware and there is order aware. If order is not important, we use precision at K, recall at K. And if order is important, we do NDCG or MMR at K or map at K. It's sort of, and K refers to in the top 5 results, what was the order of importance of the hotel results which we had, right? But the biggest thing which we had, which we felt, or the biggest concern that I have in building this model is I don't have a golden data set which already have an information that based on this query, a particular query, this is the best hotel that it should be. And that is the biggest challenge when you have your own custom data. You do not have a benchmark data set. You only have a benchmark data set, which is created by researchers. And what they do from that is that they overtune and fine tune on the specific models. However, in order for your data set to work, or for the model to work on your data set, you need to create a set of your own you need to create a set of your own queries. So for example, you need to say, I want to stay in a hotel which is close to the Eiffel Tower. So you need to create like a ground truth value, as you have in predictive modeling, where you have a certain set of features and you have a label that is assigned to it. Similarly, we want to do the same thing over here. We want to create a set of a classification model, or a set of features which identify that based on this, this is the best answer for it. So that was the biggest challenge we had. And what I did over here is that I used sort of this is a methodology called BEIR, BEIR, which is a heterogeneous benchmark for zero-shot evaluation of IR models. And in that, there is this portion which explains how you can use T5 to create your own data set. So what you do, what we see at the top is you have a corpus, you have a large corpus of reviews for each individual hotel. You use those reviews to use T5 to build questions about that you can generate from the reviews. So reverse engineering the reviews into questions. And then you use those questions to create sort of a silver data set or golden data set, which basically has question and the hotel name, question and then another hotel name, so on and so forth. And we use that information to sort of fine tune our models to come up with the best approach. So based on this, I was able to build something new. And as we go further, I wanted to show you all something that we have, which exists at this moment and sort of has been working for us. So if you go here, this is a live website. You can go check it out. So when we go, this website opens up, and in this website, if you say there's always, so you say Eiffel Tower with free breakfast, or actually, let me just say near Eiffel Tower with the view from a room. So you get an answer, you start seeing an answer. So the first answer you get is a luxury bed and breakfast, which is situated a few steps from Eiffel Tower. So you actually see that this is relevance wise, this is sort of coming very close to what you have asked. And within the reviews, we also sort of sorted the reviews in a way that it comes close to, so this is not based on the recency factor, this is based on the fact that what is a relevant review for you. So it was my family's family of six first time in Paris, and we booked 3 rooms and loved everything about it, beautiful and historical view. So and so it sort of basically gets closer and closer to the relevancy level that you're looking for. This one was a quick walk to the Eiffel Tower. So you start to see that all these reviews have something that really refers to what you're asking for. Again, this is a breathtaking view of the Eiffel Tower. So basically, this hotel also it's close to it, and then so on and so forth. I can actually show one more example. Basically, if you want to stay near the Louvre, so you go here, say near the Louvre with great shopping options and high-end rooms. So you search for that and everything changes, and you start to see that this sort of is close to the information. So you can't be the location of the hotel right near the Louvre, extremely comfortable room with all amenities. So basically, you get an answer which is really close again to what you've searched. And that is what we're trying to do. We're trying to build a system which is really close to what your actual queries is, as if you were talking, you're speaking to it as you are a human being, and it's able to understand what your request is. Now, coming to now let's say I have I have a website, and I have an idea. How do we sort of merge that journey to make it into an API? So over here, unfortunately, I got disconnected. However, over here, what I have is I there are a few steps I take, and I can take you all through them very fast. So basically, the first thing I do is that I generated embeddings from the reviews. So if you see over here, you see the word the column embedding. So for each hotel, I basically had different kind of information about that. Actually, I can run some part of it right now. So for individual hotel, so for individual I have a review ID, I have a review rating, I have a title, and then I have the name of the hotel. What is the ID of that hotel? The description of that, the rating, the how many ratings do we have, the different features, and then this combined text basically is the is the I actually show you all. Combined is basically the information about the hotel itself. Sorry, I wish I had it better. So if you see here, combined is nothing but the combination of the title and the text of the review itself. Title: good hotel with rude waiters. Content, and then the content is: we went to this hotel just this month. We have three junior suites, and the hotel is very weird. So basically, this is the review, and the embedding is the combination of putting it all together. The embedding is this review and title converted into the embedding using an OpenAI or whichever LLM which is needed to build that. Once we have done that, I've created a function which basically takes in a query. So you have a query close to the Louvre and great food nearby, but not too expensive. Let's say we have that example. And what I did is, this is the easier part. You have a function which embeds the query in real time. And from the query, what we are able to do is we are able to compare each one of the embeddings of the hotel with the cosine using cosine similarity, and then we just sort the results. So actually, it will probably take a while to run. But we have this a version over here is basically what you can do is you have the query, and based on the query, you can sort of create something. I'll show you an example towards the end. We have something called Guardio, which is an API builder. It's right here. So there is a tool with the name of Gradio. I use Gradio to put the function of the search within that. And once you put the search function within that, it sort of creates this embedding which looks like this. And what you can do is you can go onto the query, and it's basically the same query which I have at the backend of the previous website I showed, which is over here. What this is doing is that you can write the query, and it will give you a JSON output of what the results are. From there, what I do, so this is an example. You write hotel near the Eiffel Tower, and it sort of gives you a description, the relevant scores, the ratings, and the relevant reviews to it. This is the JSON output which we get. In order to make this JSON output available to us as an API form in a consistent way, what I do is I actually went to Hugging Face, and in Hugging Face, you can start a new space. And within that space, you get to upload all the data files. You have a README file, which says this is what gives you information about what the API is. From there, what you can do is you can write a very simple Gradio app tool, which will work for you and have all the information. I mean, literally, this is all I'm running, and this is the same function. I call the embedder, and then I introduce the function, and I just return the entire function. So this is all the code I need to write in order to create the cosine similarity measure. And once I have done that, there is one more file which is needed, very important, which is the requirements.txt file. This requirement.txt file is sort of all the different packages that your model will need to run. Once we have all of that put together, we have a query up and running. For example, hotel close to the Louvre. And once you have that, you start to see answers jumping in. This is the same information as you saw previously. And what I do from here is that this website that I'm running at the back end is getting the same results. All I'm doing is sort of cleaning up the look and making them come out like this. And this is the basic idea that we have over here, is that we sort of take step by we go step by step. We first introduce these we first create a semantic model based on, we take the embedding, we take the query, we sort of create embeddings for both of them, and then we use a version of cosine similarity to sort of create a basic model that sorts the data and uses that to showcase your results. And this is a very basic model. This is not something that I have used any fancy way of doing it. But even with doing very basic work, I was able to create a model that sort of depicts on what we are going after, and sort of, works the way we would like it to be. Or at least directionally, it is giving us good answers, which is the expectation currently from neural search models. Now coming back to my presentation, I want to mention about the next few things which I've been working on. So there is we've all heard of multiple versions of summarization. ChatGPT offers very good summarization. However, it could be very expensive to run summarization from ChatGPT as an API. So there are other models such as BART, BART. And what we can do with BART is basically we can create an offline version of summaries, because you don't, once a summary of a hotel doesn't change over time. Maybe it takes 1 year that you would like to update, or 6 months you would like to update it, but it doesn't have to be updated on real time. So APIs are expensive to build, especially when it is a paid API. So what I did is that I used summarization technique to sort of create something in the backend, and I have it up and running again. So I've another example to showcase real fast. So let's say you have this information over here, and I just write, this will run. All right, so this ran, and this time what I have is I have the hotel name. So this is a building further. You have the hotel name. You have the summary of all the reviews that are there, and then you have the relevant reviews based on that information. So remember, hotel near Eiffel. This hotel is literally, you can actually see the Eiffel from the room. So you can sort of slice and dice the data in different ways and sort of build information based on what you have. And this is an added overview to, so let's say I took the reviews and I built one more thing on top of it, which is sort of a summary, which is not the same description that you get from the hotel, and sort of based on what the users have said. One more thing, one challenge we faced was that you can have a lot of fake reviews. People can give fake reviews and you wouldn't know what they mean. So we've sort of tried to take care of it by building a model that sort of removes the reviews that we feel might be sort of fake ones. Right. So this was on some summarization. Another very fun thing that came up was a set of reviews that I was looking at. So when we look at each review, there is some information that we can derive, but systematically going through every review and making something out of it is really, really difficult. So there's a new technique which is called aspect-based sentiment analysis. And in that, what we do is that we can take information from every single review and sort of see what that review is referring to. So for instance, in one of the out of these 4 reviews, 2 reviews mention about staff. So, and they're both positive. Then there are 2 reviews which mention about location. They are both positive. Similarly, only one mention about breakfast, which is the first one. So we take that information. So, and that's a positive. Then we take the mattress information, which is in a different which is in a different review. We take that. However, in the first one, when someone says mattress was too soft to my liking, we actually gave it a negative connotation. So what we can do from here is this is beyond sentiment analysis. This is sort of taking different aspects, which is it is identifying them itself. I did not tell this model that these are the aspects I'm looking for, but it is able to identify those aspects itself from the reviews, and using that information from the reviews is able to come up with sort of like a numerical value eventually, which is how many positives do you have, how many negative you are, and you can sort of give a score yourself to the different aspects of a hotel, which is something that we don't get from the current way, because either you get sentiment of overall 1 or of 0, which is good or bad or whatever, 1 or negative, but you can go deeper than that. And this is where you're getting this information that not all reviews give all the information, but you pick up the information that you have in every review and sort of go from there. Similarly, another example is the mountain hill was good, but the food was really bad. So this package, what it does is that it's able to identify that there is a mountain, and that's what we're talking about, and that's the positioning of the text. The was good, so there's one sentiment which is good, but the food, now we know there's another aspect or expression, and we know that it was bad. So it's a very nice way of working with this package that is able to identify, and it's really good when we're trying to build information about hotels and going from there. Another thing we have is, we all know what keywords are. We have all seen keywords, but what if we could get key phrases also? So this is again something that we can utilize is, we can sort of build something called a key phrase transformer. The key phrase transformer sort of uses the information that is in the reviews and is able to identify key phrases. Now, ChatGPT also offers something similar, that you can give it as a huge corpus and it can return you certain reviews. However, within that, there are certain challenges. For instance, the first challenge you will have in key phrases in ChatGPT is the fact that you will be truncated. So here, what we can do is we can work on this we can work on these models offline, and you can build all this information for us using relatively very cheap hardware. You can do it on your own machine also. You don't have to use something as advanced as ChatGPT to help you do that, because you do not want these answers at real time. You can make corpus and you can make embeddings of them and you can store them, and you only call them when you need to. And storage is very cheap. So it's always useful to use this information in a way that you have stored, you have created offline models, and you are going from there. And the link is, this is the same link which I have, which is where I am in the hotel building up, and this is how it works. Actually, I could show an example real fast over here.
Okay.
So for instance, I have a hotel, and so I built a search engine for finding a hotel in Paris.
Mhm.
So I think I can ask you, do you have a query? Let's say you want to go to Paris and you want to give it a query, a free flow query. What would that be?
Anything, and I would want to be within 2 kilometers of the Eiffel Tower.
All right, so close. So so the first thing you started is close to the Eiffel Tower. Literally, what you search, the thing that we search, it is able to get you that very, very fast. And this is like running live in real time.
Mhm.
It's giving you the information, right there. And this is the strength that I was trying to identify, that this is how we can build neural search models, which makes them relatively very contextually strong, and you can get results fairly cheap and very close to what you're aiming for. So the second result also situated within with a few steps from the Eiffel Tower, right? Then you have the third one, which is a 10-minute walk to the famous Eiffel Tower. The third is also stay at the Pullman Paris Eiffel Tower itself. It has a name in it. So all these results you're seeing, they have this thing about them, is that it's really close, and it's giving you the information that you're looking for. And imagine if we could reduce your space search to maybe 10 hotels rather than looking through every single hotel that you have in your list and trying to understand what it really means to be.
Yeah, rather than searching on Google and
Yep.
getting the Yelp reviews and having to go through
Yep.
every single
Yep.
little one.
Yep. In fact, what I've done is that I've sorted the reviews relevant to what you're aiming for. So
Mhm.
somebody in my class actually asked, good spot or good hotel to propose. And I was like, I don't know if people would write that. And I mean, the closest one we got was we just had to write a review after we got engaged at this hotel during our recent stay.
There you have it.
Right. Another person that asked me is that, hotel with pet friendly rules. Right. And then I don't know if if I'll be able to get the right answer for this, but I think there was one that we actually got very, very close to. This one I don't think has that information. Right. So you get that. The other one,
Mhm.
it's dog friendly.
Yeah, that's very cool. As a pet owner, I would definitely love to have something like this where it's just like, give me all the hotels that are dog friendly within a certain area, rather than having to dig through all the little fine print
Yep.
and everything.
And especially when you have a review that sort of informs you of that, you're like,
Mhm.
okay, this is exactly what I'm looking for.
So I'm seeing a couple questions come in now. So how do you deal with fake reviews?
I actually built a model to sort of work through that. I've actually built a model that sort of, it's a classification model with a certain level of confidence. If this is a fake review, remove this,
Yeah, yeah.
right? If it's also beyond a certain number of tokens, I just remove that also because the embedding will sort of not be able to read through it. So I don't use it at all then. There is a GitHub that it's a work in progress. There
Okay.
are multiple, the thing is that, every other month there is a new LLM model that comes out and starts to exist, so I basically have to update the GitHub and so on and so forth. So I think if you reach out to me, I'll be happy to, sort of work with you and showcase and what this is happening.
Mhm. Okay, sounds good.